Okay, 5.2, we're talking about functions. We're continuing our lessons on relations, right? We talked last lesson about how the elements of one set can relate to the elements of another set, and the description of how they're related is called a relation, right? There's an association. Well, now we're going to talk about a special type of relation called a function, but before we do that, let's take a look at two definitions that we need to understand. Okay? The set of first elements of a relation is called the domain. This is very important. Many students throughout high school get domain and range mixed up. A lot of kids don't really know the difference, and there's not a lot of instruction, I don't think, on domain and range. It's not brought up very often. So this is what they are. The first set of elements is domain. The set of related or second elements of relation is the range. So again, the first elements, and if you're talking about arrow diagrams or tables of values or the points, right? Sorry, what am I thinking of? Ordered pairs, thank you. Ordered pairs. When I'm thinking of ordered pairs, it's always the first one that's listed. That element is from the domain. So the domain is the first or initial set. Okay. Now, a function is a special type of relation where, and this is really important, each element in the domain is associated with exactly one element in the range. So each element in the domain is associated with exactly one element in the range. No fewer and no more, but exactly one. And as we move through this chapter, and as you move through math in high school and university or whatever else you're going to take math in, functions will be very, very important. They model lots of real-life situations. Functions, we can have a mathematical relation between two variables, and functions are often, the ones that we focus on. We let the relationship, if it's mathematical, it's often a function when we graph something or when we're associating things with real life situations. So functions are important. So let's take a look at what this looks like, a function, and let's explore domain and range. So again, this is an arrow diagram, right? And the set of numbers here on the left is it the domain or range? The set of numbers. This is the one on the left, or the first set. It's the domain. Okay? So the domain, and this is, over here, the range. Right? Come on, black. Range. Okay. All right. So this is the range. Now, this right here, okay, is this a function? Is my question. So we have numbers 1 to 4, and the association is the number of wheels on, and then over here we have bicycle, car, motorcycle, tricycle, unicycle, so on. All right, so is this relation a function? So think about this. Does each element in the domain have exactly one range value that it's associated with? Or are there any domain values that are associated with more than one? So the answer is this. Look at this right here. Number 2 is associated with a bicycle. A bicycle has 2 wheels. Number 2 is also associated with a motorcycle. Okay? So this is a case where this is not a function. This diagram does not represent a function. Okay? Again, one domain value is associated with only one range value. Now, if we did this in the exact opposite order, okay, same thing, but we use this as the domain and this as the range over here, the numbers, then a bicycle has 2, a car has 4, a motorcycle has 2, a tricycle has 3, and a unicycle has 1. So notice that there's only one arrow coming from each element in the domain. One arrow. Over here there was 2 arrows coming from one of them, right? And so this one is a function. This represents a function. Because there's only one arrow coming from each. Okay. So that's what a function is. The domain is always the first set of values. Okay. And we'll do lots more exploration of domain, range, and functions as we move through. Okay. So make sure that you have this understood. A function is a special type of relation where each element of the domain is associated with exactly one element in the range. Okay. Questions? Okay, can I move on? Am I still copying anything up there? Okay. I can come back later if you're still working on something. All right, so let's keep going. Let's do an example here, okay? An example. So for each relation below, determine whether the relation is a function and justify your answer. And identify the domain and the range of each relation that is a function. Okay. So in A, we're given a list of ordered pairs. Okay. So remember, one domain value goes only with one range value. So here's the relation. Associates given shapes with a number of right angles in the shape. So here we have a right triangle has one right angle. An acute triangle has 0 right angles. A square has 4 right angles. A rectangle has 4 right angles. A regular hexagon, 0. Okay. So is this a domain? Is this a function or not? Okay. So I have a yes and a no, and from the same person. Okay. So what's your final answer? Yes or no? What do you think? Yes? Okay, you are right. It is. Now, why is it? Because I have 4 as shown up more than once. And I have 0 that's shown up more than once. But notice that there's for every domain value, there's only one number associated with it. So think of it this way. In the list of ordered pairs, if you only see the first word or first number mentioned once, then it's a function. Okay? So in this diagram, if we were to make this diagram, there would only be one arrow coming from each thing listed in the domain. So in ordered pairs, if any of the x values or the first values are listed twice, so they have 2 partners, it's not a function. If they're only listed once, it's a function. Okay? So this one's a little bit easier to look at, or to gauge from. Is this a function? Well, we have multiple arrows coming from more than one number here, right? So when there's more than one arrow coming from there, this is not a function. So not a function. And I will abbreviate function sometimes just fxn, just in case you're wondering. And this is a function. Okay? So the other thing was identify the domain and range for each relation that is in the function. So this is how we're going to show domain and range. We're going to put a capital D equals, and we're going to list the elements in the set. And so we use the braces. Okay? And yes, you have to do it this way. Do not use regular brackets. You have to use braces. Please use a capital D. Don't use a lowercase d. Do it just like I'm doing it, okay? This is math notation that is consistent. Okay. So let's list them. Right triangle. Okay, I'm going to abbreviate that. Acute triangle. Square. You see how I'm just listing them, and with separated by a comma. Rectangle. And regular hexagon. And at the end, you put the closing brace. That's the domain. Right? Now with the range, for the function, do the same thing. Capital R, uppercase, left brace. And we list the values in the range. Now remember, you only have to list them once. Okay? Don't list them more than once. So we have a 1, we have a 0, and we have 4. So let's put them in order. 0, 1, 4. Only list them once. All right? Questions? All right, let's keep moving on then. That's good. No more questions? Okay, let's take a look at this page on your textbook. What page is this on here? Where did I get this from? Oh yeah, page 267 in your textbook. Okay. So let's take a look. Let's examine here this situation. Okay. So in the workplace, a person's gross pay. Have you ever heard of that? Gross pay? Okay. Gross pay, the other kind of pay is net pay, right? So the gross pay is sort of what you make per hour, whatever. It's the total amount of money that you earn. The deductions would take away from the gross pay to leave you with what you have left over, which is net pay. Okay? So gross pay is total value of money. It depends on the number of hours worked. Okay. So we say that P, okay, so that would be your payment or your profit, something like that. The pay, sorry. P is the dependent variable. Okay, so now we're going to talk about independent and dependent variable. Since the number of hours worked, H, does not depend on the gross pay, we say that H is the independent variable. So there's two types of variables we're looking at, the independent and the dependent. The X variable, or the domain, is always the independent variable. Okay? So the domain is the independent variable, or the elements in the domain are the independent variables. The domain represents the independent variable. Okay, so this is the domain. Now, it's independent because usually when you're talking about a situation and you're talking about pay, this is what you say, okay, how much money did you make this week? Well, you think about how many hours you worked first, right? Well, I worked this many hours, I get this much per hour. Okay, here's my pay. So the independent variable is the one you start with in calculating these sort of things. Or it's the one that is the, it is not the dependent. So you think about the dependent. Okay, gross pay depends upon how many hours you work. Right? So this is the one that's the result, and this is the range value. Okay, so the range is the dependent variable, and that's like the Y. Okay? So domain is listed first. It's also called the independent variable. The range is listed second. It's also called the dependent variable. So if you work 3 hours, you get paid $36 at $12 an hour. If you work 5 hours, you get paid $60. Do you see how this one depends upon this one? Okay. So let's think about something else. Let's think about rainfall and month of the year. Okay. Which would be the domain? Boys, are you guys listening back there? Everyone listening? Yeah? Are you listening to me? Okay. So, question? Rainfall and month of the year. Which is the independent variable? Which one would you think you would start with in that situation? Sorry? Month? Okay, does anybody else vote month or somebody else vote different? Okay, who votes month is the independent variable? Think about it this way. The dependent variable is also the one that you would measure. Okay? So the one that you would measure in the situation usually is the dependent variable. So yes, rainfall depends upon what month you're in. Okay? The month does not depend upon the rainfall. Very important. So we don't get to the end of the month and say, how much rainfall did we have? Okay, we had lots of rain. So that means that this month is going to be April. Right? You don't say that way. You say, okay, this is April, and so what is the amount of rainfall that we have there? That results from the time of year. Make sense? Independent, dependent. Very, very important. Okay. Sometimes it's tough to tell, but it's usually the one that you measure or the one that depends upon the first variable. Any questions? All right. Okay, a function. A function is like a machine, okay? So you can just jot down whatever you want here. You don't have to copy all this down, but I want you to listen and jot down some notes that you kind of take from this. A function is like a machine. So consider two machines that both accept quarters. And this is in your textbook as well, page 268. Machine A calculates value. Okay? Machine A calculates value of the quarters. Machine B does something different. It calculates the weights of the quarter. So this is machine A right here. Each machine performs a different operation, so the machines represent two different functions. Machine A, you input certain values, and that would be the number of quarters, right? What the machine does is it calculates the value for you, okay? And what you would do is you would put, if you had 3 quarters, you would multiply that by 25 cents or $0.25 to yield an output value of the value of the quarters for 75 cents. So you have independent and dependent variables, but you also have input variables, okay? So the x is also the input variable. You might want to jot this one down for sure. Is the input variable. Okay, so the x, the domain, the independent, is the input variable. The y is the output variable. Okay, the y is the output variable. So here's the math description here of the function. V equals 0.25q. Okay? The input variable is the number of quarters. What the function does is it finds the value by multiplying the number of quarters by $0.25 to give you the value in dollars. Okay? So x is the input, y is the output. Now, here's something interesting. I don't know if you've seen this before, but another way to write the output variable is like this. So notice that this is not x and a y or a quarter and just a v. This is v with q in the brackets. Okay, so that's something else we're going to talk about here real quick. I think just next. But this is called function notation, and it has the input variable and the output variable written together. Okay, so I think let's take a look at the second machine first, and then we'll talk about this, okay? Oh, no, I guess I do function notation now. All right, so function notation. So this v of q is function notation. All right, make sure you write this down. Function notation. And the great thing about this is that you have the input variable. Okay, so that's the input in here, and you also have a representation for the output. Okay? But in reality, this whole thing represents the output. It just will show you what value you put in, okay? So let's take a look at it over here. So function notation, instead of doing y, sometimes we do v of whatever the input variable is. And so you would say v of q is equal to 0.25q, v of q, v of q. Or another one you'll see a lot is this, f of x. Maybe you've seen this before. Function of x, f of x. It's another way that you'll see it. So, the good thing about this function notation is, again, you have the input variable written in the function notation. So v of 3 means that 3, see, 3 was the input variable, so you put 3 into the function, and then you calculate. So if we had 3 quarters, the value would be $0.75 or 75 cents. Okay. So what would be v of 4? Well, that would be 0.25 times what? what would I put in there? 4, because that's the input variable. And so v of 4 is what? 1, right? Or $1. So you have the connection between the input and the output. All right, so that's function notation. The other option would be function notation. Let's say v of q would be just maybe a v with no input variable listed. That would be this would be non-function notation. Okay, this is function notation. This is not function notation. Not function notation. Okay, another type of function we could have with quarters is, as was mentioned here, they're weights. If you have a number of quarters put in, and if each quarter was 4.4 grams, then you could quickly find out how much they weigh. And here would be the function notation for the output variable. Notice that we have another capital letter. This is uppercase usually. Well, always. We'll always keep that uppercase. And M would represent, something that would be reasonable for the letter. So in this case, it was mass. The V was what? Value, right? So M would be mass. And it's the mass when you put a certain number of quarters in the machine. So M of Q in function notation is equal to 4.4 Q. For every quarter you have, you multiply it by 4.4 to get the mass. Okay, any questions? All right, let's take a look at an example where it kind of integrates everything we've learned here today. All right, so the equation V equals negative 0.08 D plus 50 represents the volume in liters of gas remaining in a vehicle's tank after traveling D kilometers. Okay? So we have D is our input variable, and V, the volume of gas remaining, is our output variable. Does that make sense? So the volume of gas that you have left depends upon how far you drive. The gas tank is not refilled until it's empty. Okay. So describe the function, write the equation in function notation. Okay? So when you're describing the function, you would say just like I said there. After you've driven a certain number of kilometers, V represents the amount of gas you have left in your tank. Okay? So if you drive a certain distance, V is how many liters you have left in the gas tank. That would be a description of the function. I'm not going to make you do it right now, but that would be a description. Write the equation in function notation. Okay, so this is actually pretty easy, right? Look at what we just mentioned over here. Okay, this is function notation, and this is not function notation. So which is this one in right now? This is in not function notation. How would I write this in function notation? What would I have to do? Answer? No? Oh, you were drawing something in the air. I thought you had the answer. How would I write this in function notation? Anyone? What would have to change? Would I have to change something over here? No. Would I have to change something over here? What's different in function notation? Sorry? Yeah, V of D, right. You have to show the input variable in with the output variable. Okay, guys, it's not hard. Look at, this is V. So function notation is V of, what's the input variable? Look, it's right over here. So V of D equals, you write the exact same thing you have over here. Okay, that's function notation. Okay? Got it? Is this hard or is this just Monday? What is this?
Monday.
Both? Okay. All right. Okay, so what do you suppose this means? What does this mean right here? V of 600. What does that mean? What does the 600 mean? Sorry? Nice and loud. Kilometers. Okay, so 600 is the value for D, right? This is the input value. So V of 600 equals negative 0.08. We're going to put 600 into the machine. Okay? So this right side is the machine, and it does the work on the input variable. So V of 600, this doesn't change. You always stay at V of 600 so we can see what the input variable was, and then you evaluate this. Okay? So what's 0.08 times 6? Equal 48. So negative 48, is that right? Plus 50 equals 2. So V of 600 equals 2. What does this mean? What does this, Jake, what does this mean? What does this answer mean? In words, what does it mean in words? Don't know? What is the 600? Okay, kilometers. What is V of 600? What does this number represent? Liters of? Okay, this is why I need you guys to pay attention back there, okay? This is very, very important. This is a lot of English stuff. This is very important, especially for you international students, okay? I need you guys paying attention. This whole function, okay, represents V liters is the gas remaining in a vehicle's tank after you've driven a certain distance. So, what this means is that after 600 kilometers, the car should have 2 liters of fuel remaining. Okay? That's what it means. Now, if we didn't have function notation, and here I'll just explain why function notation is really good. If we didn't have function notation, we would have V is 2. And you would interpret this as the number of liters of gas left in the tank is 2. But you wouldn't necessarily know how far we've gone. So, function notation shows us what the input variable was as well as the output. Okay? All right, finally, this one's not the easiest one, but here's C. Determine the value of D when V of D equals 26. Okay. V of D equals 26. So 26 is the amount of gas remaining, right? Remember, if V of 26, if this is V of 26, I'm sorry, this is V of D equals 26, I can literally put 26 right in there. So it's going to look like this. 26 equals negative 0.08 D plus 50. Okay? And so this is determining the value of D. Okay, so how do I solve for D? How do I find D? What's the first step here? Subtract 50, right? Subtract 50. What's 26 minus 50? Negative 24. Good. Equals negative 0.08 D. Now I have this dividing, so I need to, multiplying, so I need to divide both sides. So D equals what? Oops, clear. So 24 divided by 0.08. Of course, they're both negative, so it's going to be a positive. Okay, does this look right? 300? All right, so what does this mean? That's the distance that you would have gone if you have 26 liters left in the tank. Excuse me. All right. So this is a very important example. It talks about function notation, right here. It talks about the output value when you have an input. And it talks about the input value when you're given an output. So this is a very important example. You need to know how to do that one. Okay, any questions about this? Any questions? All right. Okay, so here's one last example that I'll give you here. This is from your assignment. It says, write as an equation in two variables. Okay, so I did mention that we're always going to use capital letters. You will see function notation without capital letters. Most of the time, I'll say that most of the time we use capital letters in this section, but not always. So write as an equation in two variables. This is function notation. What they're looking for is not function notation. That's what write the equation in two variables mean. So for 7a, you could simply do d. Just drop the bracket t. Okay? That's right here. There's the answer. Just drop the bracket t. You don't want to put the input variable in. Okay? And for b, writing in two variables, really easy. Just drop the bracket with the input variable. Drop it. And write the rest here. Okay? So those are your answers there. And just in case you're wondering about that. Okay, so you'll have some work on domain and range and function notation. So I'll give you your assignment here. Okay, I'll show you your textbook here in the video, so if you want to do some work at home, if you forgot your textbook, here it is. Number 4. Just give me 1 second.